Consider the statement, for every integer n, if n squared is odd, then n is odd. Write what you would suppose and what you would need to show to prove this statement by contradiction. So in a proof by contradiction, we have to suppose the negation of the statement that we're trying to prove. So let's first identify the negation of the original statement. Since my original statement is universally quantified, that means the negation is going to be existentially quantified. There exists an integer n such that, and now we have to negate the propositional statement, if n squared is odd, then n is odd. This is an if-then statement, and so the negation of an implication would be n squared is odd and n is not odd. And if n is an integer and n is not odd, that's just the same thing as saying n is even. Now, since this is the negation of the original statement, that means that this will also be the assumption for my proof by contradiction. Now, what is it that we need to show? Well, we need to show a contradiction. Now, there are many different contradictions that we can get. For example, we might show that 1 equals 0. That would be a blatant contradiction. Part B says, write what you would suppose and what you would need to show to prove this statement by contraposition. So contraposition is when we swap the if and then, and we negate both sides of the implication. So our assumption would be that n is even, since that is the negation of our conclusion. In the contrapositive, the negation of the conclusion becomes the assumption in the implication. What we need to show is the negation of what was originally the if part of the if-then statement. So we need to show that n squared is even. Thanks everyone, and I'll see you in the next video.